this tutorial, you will learn how to calculate a chi-square test of independence. You will first need to begin by already having created a contingency table for your data. Please watch the video on creating contingency tables and pie charts prior to completing this video. We already have created a table of counts for our data, and now we will copy this table into a new sheet. So copy your table, add a new sheet, and paste it. This data is our table of observed counts because this is the data we collected in our survey. The next thing we need to do is we need to copy this table several times as we will use it to create our other tables. So we'll copy excluding the grand total, twice. Now we can rename our tables. This will be our table of expected counts. And we can go ahead and delete the values that we had here originally. And then we can delete the values from our final table, which this will be the table where we calculate the chi-square statistic. We create a table of expected counts based on the assumption that the conditional distribution for each of our groups will be equal. In order to calculate this, we use the formula row total times column total divided by grand total, and we'll need to do this for each cell. So this will be equals our row total, which was 33, times our column total, which was 43, divided by our grand total of 76. Now we can copy this formula across these cells, but by just originally doing this before we change anything in our formula, it will update and drag the formula to different cells. So it will include, instead of cell E2, it will include cell F2. So to prevent this, we want to lock our cells. So click on the cell in which the equation is in, and then up in the formula bar, click between the letter and the number. On a Mac, you'll select Command T, and on a PC, it'll be function F4. This will give us dollar signs, which means now our equation will be locked to that cell, which is the row total. We'll do this again for our grand total. Again, it's function F4 on a PC, or it's Command T on a Mac. And then we'll just click Enter. Our equation hasn't changed, but it has been locked. That means that now when we drag our equation to the right, once we see that plus sign, it will copy and update only this middle cell. The other two were copied exactly. We can do this process again for the iPhone row. So again, it'll be total for the row times column total divided by the overall grand total. And again, we want to lock these cells. So F4 on a PC, Command T on a Mac, and again here. Now we can drag it across, and we've filled in our table of expected counts. Our chi-square statistic is based on the relationship between our observed and expected counts. The equation is our observed count for each cell minus the expected count squared divided by the expected count again. And again, I'm just clicking on the cells I want to reference here, and then I hit Enter. Now, because we want to do this for each of our cells, we can click on our original equation, our cell with the original equation, look for the little plus sign and drag it over, and then we can drag it down as well. You will see here I copied the equation but updated it to select each of the new cells. So for this last example, it was for iPhone and worse, the observed value for that and the expected value for that. Now the chi-square statistic that we'll calculate is the sum of all of these chi-square calculations. So we will create a new space for this and then calculate it by using the sum formula and selecting all of the cells for our chi-square calculation. In order to determine if we should reject the null hypothesis based on our chi-square statistic, we need to find our degrees of freedom so that we can get our p-value and our chi-square critical value. Our degrees of freedom are equal to the number of rows minus 1 times the number of columns minus 1. So we have the number of rows here is 2, iPhone versus Android, 2 minus 1, times the number of columns. Here we have better, no impact, or worse, so 3 columns minus 1, leaving us with the degrees of freedom of 2. To calculate our chi-square critical value, we will use a built-in equation in Excel. So this is equals chi SQ Here we'll use our alpha value of 0.05 and then our degrees of freedom we calculated. So our critical value is 5.99. We can already tell that our chi-square statistic is larger than this, so we will be rejecting the null. But we can also go ahead and calculate our p-value. This is done by using another equation, which is equals chi SQ dot dist dot rt. And with all chi-square tests, we will always be doing a right-tailed test, so we're only going to use the .rt options. The x it's asking for here is our calculated chi-square statistic, and then our degrees of freedom. Our p-value here is less than 0.05, so we can reject the null hypothesis. There is one final way to calculate this p-value, and that's using another built-in function. This is equal chi SQ dot test. For this one, what it's asking for is the observed and expected range of our data. So we can select that, the observed, and then select our expected after the comma, close parentheses, and you can see it just gives us the p-value for our test, which should match the p-value we calculated here. Looking at the results of this test, we see that we can reject the null hypothesis, indicating there is a relationship between these two variables.